All right, guys. So we're going to pick up from where we left off from the previous class. We were looking at median of group distribution. We did first look at median of a group of numbers, and we say in order to find the median of a group of numbers, all we need to do is to arrange the numbers in ascending or descending order, that is from smallest to largest, or from largest to smallest, arrange them in that order, and then you pick out the middle number. Now, if you have an odd amount of number, then you will have only one middle number. So you pick out that one middle number to give you the median. If you have an even amount of numbers, then you will end up with two middle numbers. In that case, you pick out those two middle numbers, add both of them together, divide them by 2, and you will, whatever you get, that will give you the median. All right, now for a frequency distribution using the table, you will have to add up all the frequency to determine how many numbers you have. And for instance, if you add your frequency and you get 30 numbers, are your frequency equal to 30? It means that you would have 30 numbers. And it means that 30 would be an even number. So it means that in that case, you have two middle numbers. So you would choose the 15th and the 16th number as your middle number. So you can do that by adding up the first numbers going up to the 16 with your frequency. The first set of frequency numbers that add up to the 15th, you're going to examine those numbers and see what the middle numbers turn out to be. All right. So we would have done that from previous lessons. So just to recap. So in the case where we have this group distribution table, we don't generally try to find the middle number by adding up the frequency, but instead we plot what we call a cumulative frequency curve. And so in order to plot a cumulative frequency curve, we have to find what we call the cumulative frequency distribution. And then so we have to write two new columns for that. So the two new columns, one column going to give us our boundary values, and the other column going to give us our cumulative frequency values. And so I'm just going to pick up from here. So for this table, in order to construct our cumulative frequency values, we need two columns. So we need an extra column as I'm positioning this. So that column, we'll use that for your boundary values. And we need another column. And this column, we can use it for our cumulative frequency column. All right, so for our boundary values, we would have seen how to calculate that from previous class. So here we would have our boundary values. Can anybody remind me how we calculate our boundary values? So it's only one.
Sir, upper class limits of the class, sir, with the lower class limits of the following class.
All right.
We add those together and then divide it by 2.
All right, and there's a shortcut method to that. Well, how do we do it by the short method?
I think you said something the last time, sir, that so I don't remember a shortcut method, to be honest.
Sir,
You know, all of them go end up with 0.5.
All right. Miss Cox, you were saying something?
Sir, I think the shortcut was to times it by the lower, and then, like, for example, 154 and 155, so I would work out that and continue like 159 and 160 and 164 and 165.
All right. All right, so just let me remind you of how to do that. All right, so before we work out our boundary values, we want to treat the first class that we have in the table as our second class. So if we treat this first class as our second class, it means that we have to consider a class that would have come before this class. And if we look at the pattern of the numbers, we see that you have 154 to 155, sorry, 150 to 154, then 154 to 155. So if you look at it in that way, you notice that for the upper class limits, the upper class limit of this class, which is the 154, is followed by the next number, which is 155 for the lower class limit of the next class. So you have 154 here, then we have 155. So we can actually look at that pattern. So if we have 154 here and we have 155 here, if we have 150 here, what we would have, the number before 150, we would write it above for the other limit up here. So that would be 149. All right, so once you know this number, we only need this upper limit to find our boundary for this class that we are supposedly saying that this is the first class. All right, so once you find that number before this, so the limit of that class that we didn't have, the upper limit of that class, you only need that number to find all the boundary values for the cumulative frequency. All right, so once we determine that value, the shortcut method is really focusing on all the values in the right column. So these values in the right column, these are the values that are going to help us to find the boundary values. All right. Now to find the boundary values, what we note is that our limits, the upper limit of one class with the lower limit of the next class. For instance, we start off with the upper limit of that first class with the lower limit of the second class. The rule is you would generally add these numbers and divide the result by 2. That's a rule. But instead of adding all of them, going through and adding all of those values and dividing by 2, all you need to do is to look at the 2 values and see how much they are different by. So 140 and 150 has a difference of 1. So if you take away 149 from 150, the difference is 1. All you have to do is just divide that difference, which is the 1, you divide that by 2, you get 0.5. And because all of these are the same, they're all different. They are all different by 1. All of these are all different by 1.
Oh, you're up here. You're up here.
So because these are all different by 1, it means that the same 1 that you divide to get the 0.5, you would have gotten the same 0.5 if you divide the same 1 for all of them. So after you find the 0.5, all you're going to do is to add that 0.5 to all of the values in the right column. So, and those values are going to give you the boundary value. So for the first boundary value, we would have just 149.5. So you add 0.5 to all the values in the right column, and you get your boundary value. So 149.5. And so that is our first boundary value. The other one will be 154.5. The other one will be 159.5. The other one would, and so you see the pattern. So all you're doing is just adding 0.5 to all of this. $164.5. $169.5. $174.5. So that these would be all the boundary values that you are needing for the graph. All right, so the next thing that we want to do is to find our cumulative frequencies. Now, our cumulative frequency is calculated based on the cash register calculation. Now, as I would have mentioned, that if you go to the supermarket and you buy items and you give the cashier the items to cash, what you would generally have is that each item you give the cashier, they would put in the cost in the, they put in the cost in the machine. And then if they put in the cost for the first item, then the cost of the second item would be total. So each time you put in a value, you have a subtotal. All right, so this column is our cumulative frequency column. I'm just going to call it CF. All right, so we have to start off with the frequencies, starting with the first class. Now remember, we are treating the first class in the table as the second class. So the class that we would have started off with as the first class would have the upper limit of 149. Now that class was not existing in the table. So because of that, we don't have any value for the frequency for that class. In other words, the frequency for that class would be 0. So if we are treating this in the same way as the cash register, then our first value would be 0. And then now, over here, we would put, cumulative frequency would be, the first value would be 0. So that would be like the first item that you give the cash register, the cashier. Then you now going to add that 0 plus, so you add the first with the second, say add the 0 now, plus the second value. All right, the second value here is 8, so 0 plus 8, you will get 16. So that will be equal to 16. So our cumulative frequency value will be 16. So this will be the subtotal. Now, if you add this 16 now, say add 0 to the 8.
Sir.
Or it's not 16, sorry. It's supposed to get,
Okay.
I don't know how I get 16 then. So add this 8 now with the 16. So add the 8 plus the 16, you will get 24. So our second, our value here for the cumulative frequency would be 24. So that is your subtotal. So you're going to add that now, your 24, to the next frequency value. And then that would give you 67. Then you have that 67, or you add the 67 to the next frequency value. So that will be 67 plus 29. So that would give you what? So 96. And then you add that 96 to 4. And then that will give you 100. Now it means that the last value that you have here, which is 100, is actually the sum of all the frequency values. All right. But we actually created this column in a subtotal fashion. So each value that you get here, each value that you add would give you a subtotal. All right, now the purpose of these values in this column, you're going to plot them against the boundary values. Now you're going to plot them against the boundary values to get your cumulative frequency curve. All right. So let me see the hands of those who are those who actually are comfortable calculating the boundary values and calculating the cumulative frequency values. Ms. Cox?
Yes, sir.
Yes, are you?
Sir, I just want to tell you that I'm okay with it.
Okay, all right, very good. Anybody else? Let me see that. All right, Mr. Giovanni. I'm seeing the hands going up reluctantly. Is it that some people are not sure? All right. Ms. Waysam, are you good? All right, so I'm going to take it that everybody is okay with the boundary values and the cumulative frequency values. All right, so I think we can clear that and move on. All right, so once you have calculated all the values, the boundary values and the cumulative frequency values, then we are going to be plotting these values on a graph. Now, for the graph, remember, we are always going to put our boundary values on our x-axis, which is the horizontal axis. Ms. Cox, have a question?
No, sir.
All right, you can lower your hand for me, please. All right, so when you're plotting your graph for the cumulative frequency curve, your boundary values will go on your x-axis and your cumulative frequency values will go on the y-axis. All right. Now this table is called the cumulative frequency table. So before you can plot